Have you ever considered how seemingly distinct forces like electricity and magnetism are actually deeply interconnected, forming the very fabric of our technological world? Gauss's law is fundamentally one of Maxwell's equations, specifically the first one, describing how electric fields originate from electric charges. It is an integral part of the unified theory of electromagnetism, providing a crucial link between electric fields and their sources. The core reason for its relationship lies in its foundational role. It precisely quantifies the electric flux through any closed surface based on the enclosed charge. This law establishes that electric fields diverge from positive charges and converge onto negative charges, and that isolated magnetic monopoles do not exist. In its differential form, Gauss's law for electricity states that the divergence of the electric field is proportional to the charge density, directly connecting the field to its volume source. It essentially describes the static component of the electric field and sets the stage for the dynamic interactions described by the other Maxwell equations. Understanding this relationship means you can grasp how electric fields are generated by charges, which then interact with changing magnetic fields as described by Faraday's law, and how changing electric fields create magnetic fields as elaborated in Ampere's law with Maxwell's addition. For instance, when analyzing capacitance, Gauss's law allows you to calculate the electric field between plates based on the stored charge, a critical step before applying other equations to understand current flow or energy storage. A key insight often overlooked is that while Gauss's law for electric fields focuses on electric charge as the source, there is also a Gauss's law for magnetic fields, which states that magnetic monopoles do not exist. This second Gauss's law, though distinct, further solidifies the foundational nature of these principles within the broader Maxwell framework, underscoring the symmetry and completeness of the overall theory. This means that magnetic fields always form closed loops, with no beginning or end. Ultimately, Gauss's law for electric fields is not just an isolated principle. It is the cornerstone upon which the entire structure of classical electromagnetism is built. It provides the initial understanding of how charges create electric fields, a concept that is then woven into the more complex, dynamic interplay of electric and magnetic phenomena described by the remaining Maxwell equations. This deep connection allows us to predict and engineer everything from radio waves to electrical power,